Welcome to Scholar Opportunity Nexus. And in today's series of video, we'll be looking at the cosine rule. Looking at the cosine rule, it's one of the very important or fundamental rules that governs physics, or vectors to be specific. And we will see it in other laws such as the parallelogram law of vectors and the triangle law of vectors. So let's deal into this cosine rule. So for the cosine rule, it also uses every kind of triangle. It's not limited to only the right angle triangle as compared to the Pythagoras theorem. So you can use the right angle triangle, the equilateral triangle, the scaling triangle, or the isosceles triangle when dealing with cosine rules. So we have vectors with, let's draw this. Now let's indicate our interior angles in the triangle. So the triangle has the same sides x, y, and z. So let's say our first angle is theta, second angle is alpha, and this is beta. So when dealing with cosine rule, just as we saw in the sine rule, that's the Lamar's theorem. The Lamar's theorem, the ratio of the sine of an interior angle to its opposite side is a constant. But for the cosine rule, it goes deeper, or it's a little bit complex, but with understanding, you get how you do it. So taking the cosine rule just means that let's say a side, the square of a side. Let's see, the square of a side of the triangle will be equal to the sum of the other two sides. That's the square of the other two sides. So that will be y squared plus z squared, then minus twice the product of the other two sides. So 2yz, then cos of the angle between the other two sides. So first we take one side, the square of one side, then we relate it to the other two sides in the angle between those two sides of the triangle. So that will be the cos of theta. So this the cosine rule. So assuming we are taking another side of the triangle, let's take y. So in this case, y squared would also be equal to what? The sum of the squares of the other two sides. That's x and z. So you get x squared plus z squared, then minus twice the product of that cos of the angle between these two sides. That's alpha. Let's take z too. For z, we have same thing. So the square of this is equal to the x squared plus y squared minus 2xy cos of the angle between it. That's theta. So that's how it works. So for the cosine rule, the square of one side of the triangle will be equal to the sum of the square of the other sides of the triangle minus twice the product of the two sides, cos of the angle between the two sides. Now let's look at this triangle. Let's take this triangle into consideration. So it's a scaling triangle with sides x, y, z. We know one angle, that's alpha, another angle, that's theta, and an unknown angle. So we're asked to find the unknown angle. You know that you can, in as much as you can use the sine rule to do this, you can also use the cosine rule to do this. And in doing this, you know that the square of this, the square of x will be equal to z squared plus y squared minus 2yz, cos of the angle between it. So since cos of the angle between it is the unknown angle, or even the angle opposite to x, then you know that you can use cosine rule and just use change of subjects to find theta. That would be something like 2yz cos of, sorry, to find the unknown angle. So it will be equal to z squared plus y squared minus x squared. In that case, cos of the unknown angle will be equal to z squared plus y squared minus x squared all over 2xy. Then you just do cos inverse of this expression. You get your unknown angle. So that's it for cosine rule. A very, very important rule in physics in vectors, to be specific. Thank you for watching this video, and I hope to see you in other videos.